Hello. So I wanted to try making a video about my new model. I've made a new model and I was going to make a video kind of talking through it. Some people have asked if I could do this and talk it through. So I thought I may as well do it, partly for my own sake as well. Just spent the last 2 weeks doing it, so while it's fresh in my memory, wanted to kind of like talk it out. So that's what I'm going to do. Made loads of changes. Models are this video is going to be waffly. I haven't really prepared or planned it. I'm just going to kind of go through it. It might be very long. I'll put timestamps underneath. And this video is mainly for people who are interested in this kind of thing, but I think it'll be interesting potentially for people who it's interesting to see how you have to figure out each point in FPL, figuring out the thinking that goes into it and how it all balances, how the weighting of DefCon to other things, all this kind of business, the thought process that goes through it might be interesting for some people, and even for people for grass FC types who don't really know what goes into a model. You might be able to see a little bit of like what actually happens, because I hear some people saying like models are like AI, whereas I don't think it is AI. It's like, for me, a model is just like a series of calculations, just like loads of maths in a big string of maths. That's all it kind of is. So I'm going to talk it through. Hopefully we'll get there. I've got lots of new stuff, new gear. I've got a new sound mixer, so hopefully I won't have sound problems. Although the video did freeze up just a minute ago when I was testing it, so we'll see. I may have to kind of pause it, check it, things like this, but we'll just wing it as we go. So I built a new model. I've been playing FPL for years, but the last 4 years I've been playing more engaged, and I got really interested in the last 4 years in like spreadsheets. Like FPL and spreadsheets seems to go together so well. You just got all the players on the left, and then you've got your game weeks along the top, or all the data and stuff. It's seems to lend itself. It's a very kind of, it is a mathematical game in many ways. So I built a spreadsheet before, but my last model was like a 1920 switchboard by the end of it, just like wires coming out of everywhere. I was just patching things, winging it, scraping things, just deleting that, adding an extra thing. It was all a right old jumbled mess. So I wanted to try and do a better one. I've been having ideas of how to do a better model. One of the things I wanted to do was have a model that rolls over the season breaks, because currently my last model, I had to start afresh a new season. I kind of had one metric for last season's data, but that was it. And so I didn't really have data until like 6 game weeks in, and even then that's just 6 game weeks of fresh data. It wasn't until you get to game week 10 beyond that you can actually differentiate and have a form data and a season data. And so my model was almost like not really very good at the start of the season, but now I've got it so that some of the metrics kind of roll over the season breaks. So I wanted to figure that one out. What else did I want to figure out with my model? I may have to pause this a lot because there's so much to think about. I'm going to have to remember all the things. Oh yeah, and the main thing I wanted to figure out as well is like, I wanted to break down my points prediction model into like each point. In FPL, every player has a point that they can get, and 1 appearance points, 2nd appearance point, goal points, assist points, all this kind of stuff. And each one of those points has a percentage chance that the player can get those points. And I wanted to kind of break it down like that so I can really see the percentage chance and work out, just get a kind of sense of order to the whole thing. So I wanted to do that. I've also looked into kind of speeding the spreadsheet up. So I've just bought Excel 2024, which apparently I was using 2019. So this whole model's built on 2019, so it won't be any X lookups. If you've got an old spreadsheet, it should work. This is 2024. Apparently 2019 only maxes out, it only uses 4 GBs of your RAM or something like that, and I've got 32 GBs, and so it was never using more than 4, whereas 2024 can use more or all of it or something, I don't know. So it's already sped it up a bit. That was good. I started getting into like pivot tables and Power Query, although I don't think I've actually used any Power Query. Maybe a bit, but I don't think so, because I don't like it. Like I started using it, but I just like the old-fashioned classic way of just doing the maybe it's just because I'm familiar with it. Maybe I'd get better with Power Query, but there was times when I was using Power Query and it was getting really convoluted and difficult to kind of adjust and change things. So wherever possible, I haven't used Power Query, but I have used pivot tables. They seem to be quite good. So yeah, found ways to speed things up. I've also put the whole model in one sheet. Last time I had like separate spreadsheets because I figured that would speed it up. I did an awful lot of just presuming things in the past. This time I've actually kind of asked, and I've had Claude GPT and like AI asking, as an assistant, asking questions to it, and I've learnt shed loads. Like my old model was, I suddenly realising was a total amateur disaster. But because now there's so many things that I was doing wrong, and I've asked Claude and Claude, and yeah, some really obvious answers to some things. So I'll go through all that. But speeding things up, yeah. So I had loads of different spreadsheets and linking them all together. But that apparently, you never know with AI. AI sometimes talks out of its butt, but that is apparently was slowing it down. So I've got everything in one spreadsheet now, which should speed it up. It seems to be going pretty nippy at the moment, so that is good. So I'll talk it through then. So I was just going to say a quick word about so what are models? Starting from the start, like when you first approach FPL, the first thing you think of, a noob would just go to FPL and just look at the total points. This player's getting loads of points, I'll pick him. Right, that's like the first thing you think. But then you might think, well, hang on a mo, there are some players who, if you look at total points here, burger off. Look at total points. So you go down here, but then there are some players who haven't played as many minutes as the others. They've all got different types of minutes. So you might think, well, if there's a new player who's new to the league, he's not going to be able to catch up those points. So then you might look at minutes, and then you just do this maths of like, well, what's the points divided by the minutes times by 90? So you get the points per 90 rate. And if you do that and sort by that, you suddenly get a different leaderboard. Now this is full of loads of rubbish players. Josh De Silva, and so these are people that have been skewed. Their numbers because they've hardly played any minutes. 2 points in 2 minutes means he's getting 90 points per 90. So these are all skewed. So then you apply a little minutes filter and you say, well, if those minutes are less than, I've put 500, then just put a 0 there. Otherwise, do the same thing. So then you do the minutes filter, and Bush, you've got a new list now. And now this list has Osula at the top, Marlin, Marmouche, different players, Gamoa, Cherky. So this is their points per 90 rate. So there's a different question you're asking there. If they're going to start every game, then they're going to, if they carry on at this rate, it's better. So this is like models, this is how they begin. And then I did a very, this would be a very simple XG, just, your first model. So this is the next stage. You got your players, positions, teams, and the minutes. And then you basically got, these are the basic points. You got appearance points, goal points, assist points, clean sheet points, DefCon points, bonus points, and all the rest I'm just going to ignore. Save points, yellow cards, red cards, own goals. They're just periphery. I'll ignore them for now. And in a very simple model, you do your appearance points. This is what I did in my first model as well. Just give everybody 2 points, because any player that isn't likely to get 2 points, you're probably not going to pick them anyway. So just make it easy. Give everybody 2 points. Done. Goal points. If you're turning XG into goal points, which is what you probably want to do, you take their XG per 90 and then multiply it by however many points they're going to get. If it's 4 for a forward, 5 for a mid, whatever. So the XG you get from the API, which I'll show you how to get in a minute. But this, they've got like I'll show you in a minute how to get the data. But they've got like an expected goals column there. So you look up the expected goals. By the way, I'm using index match now everywhere. I was using loads of VLOOKUP, and apparently index and match is better from what I've heard, and it does seem to be better because it just index and match just searches for the column you're after most of the time. If you just want one column, just that column, just the lookup, it's rather than searching like loads, a massive kind of table of columns and rows. So that speeds things up as well, index and match, and it's quite easy. Now that I've gotten used to it, it's pretty easy. So expected goals per 90 is they've already got it per 90 in the API data. And then this one is like, if well, I've got the elements here, because the API give you, they don't give you the position, they give you the elements. So I'll just go and by that. If it's a 4, that's a forward. They get 4 points for a goal. If not, if the element says 3, that means they're a midfielder, give them 5 points. And if not, give them 6. Technically, goalkeepers get 10. I'm just going to ignore that, keep it simple, because they're not going to get goals, so they just get 6 points for a goal in this model. All their XGs are 0 anyway. And there you go. And then you just multiply those two together, and you get, that's the expected goal points. So Haaland was averaging 0.78 goals, XG, expected goals per 90. He gets 4 points for a goal. So his predicted points, he's got 2 points for appearance, and he's got an extra 3.12 points for goals. So he's already up to 5.12. Then you do the same for assists, exactly the same. Expected assist columns, times it by 3, every player gets 3, multiply it, done. Now this is interesting. This was something I was doing totally wrong, and I found, thanks to Claude, there's a really simple solution. I think so. I've only just started using it, so we'll find out if it's right, but it seems to be. So XGC is clean sheet points. There's something called a Poisson distribution, which I've heard clever people talk about before. I had no idea what it meant. I still don't fully understand it. It's something to do with hump-shaped graphs, and it's a certain pattern that occurs naturally in kind of like random things, random distributions. They naturally form this kind of hump-shaped curve, and it applies to certain aspects of FPL. You can apply it, apparently. I'm going to try it this season anyway, at least. So you get every team's XGC per 90, which, so this one I'd had to use a table, understat. Again, I'll show you where you get this data from. This is a table, so I'm using understat. You get a team's XGC per 90. That's what you get. And then you do this little equation, which is insanely simple. It's EXP brackets minus, and then that XGC, whatever that is, and you get their chance of getting a clean sheet in any average game. So Arsenal are the best, 0.87 XGC. It converts to a 42% chance of a clean sheet in any given game. Sounds about right. I mean, again, I haven't tested this, but it sounds about right. Claude told me to do it, so I'm doing it. 1.51 is kind of average, so that means they've got about a 22% chance of a clean sheet. There's probably some worse ones down here. 1.79, only 17% chance of a clean sheet. Sounds about right. And that's just an insanely... That EXP is like, it's something called Euler's number, I think, something like that. And that automatically does it to it's Euler's number to the power of minus that. I don't know how it works, but it works. It seems to work. Very simple. And before, what I was doing, I looked back through the history of like 5 seasons of data, looking at the final XGC of a team and how many clean sheets they got, and then trying to match a line of best fit through trial and error. And I ended up with some weird formula that started with like 2.5 something, take away the XGC, multiply by some sort of factor, 0 point something, I don't know what it was. But of course that was crazy. Claude was like, yeah, if you get a team that goes over that first number, 2.5 something, has XGC worse than that, then you're going to go into the negative, which is like obvious. I did some really stupid things. So if like, I think one season it might have done that. Like Southampton had like worse than 2.5 XGC. So my formula just wasn't catching that. I was just, you know, hedging, what's the word? Hunching it and slapdash, trying to figure it out. So, but that just feels very elegant, very simple, seems to work, beautiful. And I bet you that's what all the pros are doing, except they've probably got a more nuanced Poisson distribution that's been manipulated, probably. I don't know. Anyway, that's what I'm using. Clean sheet points, same thing. If goalkeeper or defender, they get 4. If it's a midfielder, they get 1, and then forward none. And you multiply it together. Chance of clean sheet, multiply by the points, get some more points. So this defender, probably Gabriel, 1.67. That's that. Then you do the same with DC. DefCons. DefCons, again, in the API, you got their defensive contributions per 90 already done for you. This one is another one where you're using the Poisson distribution. Again, I'm going with what Claude... I don't fully understand this, how it works. So a lot of this is being helped by AI. But it's the Poisson distribution. And you can convert that to a chance of getting DC. I think it's to do with like this. The reason why this one works well with the Poisson distribution is because that is already your chance of conceding a goal per 90. So it's already, and your clean sheet chance is the chance of, if you concede one or more goals, you lose your clean sheet. So it's just like one minus that, or it's just that is. I think it's almost simplified already. Whereas over here, you're looking for certain thresholds. This is how many DC per 90 you get, and then you're specifying a certain threshold of DCs you need to get. So the calculation's a bit harder. So this is 1 minus Poisson distribution. If it's a defender, the threshold is 9. If it's anybody else, it's 11 basically. Goalies, they're gonna have 0 DC per 90. Because that's how the API puts it. It puts goalies as 0. DC per 90. Yep, and then it'll be multiplying that. True. I don't know what that does. Cumulative. If it is it cumulative, yeah. I don't know. AI told me to do it. So, but that is the Poisson distribution. And I guess it's 1 minus. I mean, that comes out at like 99.99 if you don't do the 1 minus that. So, seems to work though. And there's a chap on Twitter called FPL Seba, and I was originally using his. He uploaded a conversion rate from DC 90 per 90 to your predicted chance of getting hitting the threshold in any game, and that actually matches the Poisson distribution perfectly. So, or pretty much. So I'm imagining he was using that as well. I just didn't realise that, so I was just using that. But now I know the actual formula. I'm going to use that myself. Feels a bit rough. So Gabriel was averaging about 9.07 DC, so it gives him about a 42% chance of hitting it. Some of these players, must be a defender, 11.43, probably get it 70% of the time. This is probably a midfielder, 12.41, 58% of the time. Feels right. Seems to work. So you get these two DC points for everybody, multiply it by that, done. Bonus points, last one. Go to the API, look at the bonus points. That's how many bonus points they've got. And then their bonus points is just literally bonus points divided by minutes times 90. So it's just their bonus points per 90 because it's 1 point per bonus point. That is how many bonus points they get per 90. It's 1.31 for Haaland. Yeah, it's just as simple as that. I think so. And then you add it all up. Add them all up. I think I put a minutes filter at the end here as well. If minutes are less than 500, put a 0. Otherwise, add it all up. And there you go. So that's a very simple first kind of model that you can make. And it comes out like this, and you get all the best players. And that's that's a model. Just loads of maths. But then it goes more complicated than that because you want to fine tune a lot of this stuff, and then you want to run it through the fixtures. So I'm going to go through my model. Again, I don't know if anybody's going to watch this, so I'm just going to do it for myself. Some people might like it. I'm just going to go through the whole thing. I'll leave timestamps, and we'll see where we get to. So, a model, you got to start with data, right? You got to start with the data. So the most important data is this FPL API, and you get it from here. Actually, just while I remember as well, there's some other really good resources. This chap called Vaastav, I'll leave the links below, on GitHub. He provides all the data for all the FPL seasons going back loads. You can go through the players, every single player, every player, and you got the, where is it? You got the game weeks as well somewhere. That's 26, 27. It's not on that one. Last season, yeah, the game weeks, and you can look to this merged game week. That's all 38 game weeks in one big file. And it just tells you every player, every point they got, every single game week, yellow cards, red cards, every detail. So that's really good resource, that. Yeah, very thankful for that. Another thing I just wanted to point out as well is this podcast was great. They don't do it anymore. Corridor of Uncertainty. A couple of chaps, I don't see them on Twitter much anymore, but this is really great. They talk about their models and how they do it, and they have interviews with like FPL Review, Sertalp from Optimized, FPL Chase. He's still around occasionally. Clever people, and they do podcasts and they talk to them all. I mean, the FPL Review, I didn't I thought he was like this shadowy figure that nobody had ever spoken to or didn't exist or something like. But I think he's like an Irish or Scottish guy. I can't remember. I'm forgetting now. But he's nice bloke, and he's a genius. Like he's like 20, 50 steps ahead of me. Like, yeah, he's very clever. So I can see why his model's doing well. But they talk to him, so that's a really good podcast. Anyway, coming back to my amateur efforts. I mean, look, I'm not an expert, by the way. I don't know if I said that. I'm not trained in in data, anything like that. I'm just like self-taught, figuring it out. So in one sense, I might miss a lot. This video isn't going to be like, definitive or anything like that. But at the same time, because I'm a bit of an amateur, I come at it from I need a simplistic way of explaining things. So maybe that might help. Anyway, so first of all, you got to get this API. We want to get all the FPL data. Now this website shows you how to do it. I don't fully understand it, but you click on this link and there's a JSON script. And what you do is you go to Google Spreadsheets, get a new spreadsheet, extensions, app script, and you copy and paste this app script into here if it loads. Delete all that. Copy and paste the script like that. Save it to the drive. And now when you go to your spreadsheet, there are certain codes you can write. It's all on this spreadsheet here. Like these are all the codes here. Get players, or the actual codes are here. Write players like that. Write teams. And if you type in here equals write players like that, it gets all the players. That's all the data from FPL, just like that. Don't know how it works. I hope it never breaks because, well, I just have to figure out how to do it. But there's all the data, so that's beautiful. So that's the players. Copy and paste that. That's your main API. And so I'm copying that into this API here. I've also had last season's, so you might not be able to get last season's. I can upload this. I'll upload this model, so I'll have last season's data here. So you get the API, and then other data I get is playing time from FBref is very, very good. That's really good because you kind of need that. So playing time. So yes, FBref. You go to the season that you want, player stats, playing time, and down here I always uncheck that, so I get the whole data set, and you just copy and paste this whole model, this whole table. They used to offer it as CSV, but they don't anymore. So you have to kind of like just copy and paste the whole thing. I don't know if I've done that properly, but you copy and paste the whole thing, and then you will paste it in here. I think what I normally have to do is open a new spreadsheet, a new sheet like that. Open a new sheet. This might actually open a new sheet slows the computer down. If my video is going funny right now, yes, I would normally open it like that. Hopefully not. Oops, I didn't copy and paste it anyway. I'd open a new sheet, copy it in there, and then select it all again and put it in here. Sometimes it worked. I've got Excel 24, so maybe it'll work this time. I haven't actually tried it yet. Hopefully the screen isn't buggering up as I'm doing this. We'll see. I hope this works. So, oops, what have I done? Jesus. Anyway, so that's playing time. I copy paste it in there. I do the data, sort it by minutes. It does this because they got all these headings halfway through all the time. Doesn't really make a difference. You're going to be indexing it and looking up the player name anyway, so it doesn't really matter. It ends up looking like that. So this is this season's minutes, which are obviously, well, I've just overwritten it all, put it all as 0 at the moment. CS clean sheets. This is goalkeeping, just so you know. Get rid of that one. Again, player stats. I just go for the goalkeeping one and the team ones, because I sometimes wanted that clean sheet data. Although I don't think I'm not sure I'm actually using this. I think I wanted this for my form charts, so I might not actually even be using this for this model. Trace dependence, no dependence. So I don't know if I'm actually using that at the moment. I think I wanted that for my form charts, so you could actually skip that maybe. And then the table is from Understat. So understat.com, they've got the table. and you can just download that as CSV, and they've got the XG and XGA data. Their XG and XGA data is actually slightly, they overcook it a little bit at the edges. So I've done a correction to make it match reality, which is a bit possibly wrong of me to do that, but that's what I've done. Anyway, at the moment, this season is just zeros, and then I've got them for last season. Last season's API, last season's playing time, and last season's table. I haven't got the clean sheets in there yet because I'm not using that. So that's the data. Get the data. Another thing I've done though this season with the data. Before I used to save an individual spreadsheet for all the data. This time what I wanted to do is have a massive rolling. So this is the data. This is the data bank. It's up to about 42,000 rows. I'll probably eventually get it to about 76,000 rows, which would be 2 seasons. 2 seasons, so you got like 1,000 players. I always leave 1,000 rows for potentially up to 1,000 players, because the game has anywhere from like 500 to 800-ish players, so 1,000 should cover it. And 38 game weeks is like 38,000. 76,000 would be 2 seasons. So I've got a big data bank, and I've got a little data bank form, and every game week when I upload the data, this will update automatically, this DB form, and this is just the data that I want to save for the sake of my pivot tables, for the sake of there's certain metrics: minutes, XG, XA, XGC, points played, number of games played, DefCon. Those I want to save those points so that I can have a rolling measure of it that goes over the season breaks. So if I want to know the last 6 game weeks form in game week 3, I can look at the last 3 game weeks from last season and the first 3 game weeks of this season, and it will give me that rolling over the break thing. And I can also do so I've got 2 metrics, long form and short form, because that was another thing I wanted to do with this model, was I just wanted to have those 2 metrics, long form, short form, and I want to be able to control it anywhere up to like 2 seasons. At the moment, I've only got 1 season, so 38 game weeks it can go back. But eventually, I want to be able to have a rolling. If I want to go back two seasons with the data, I want to be able to do that. Might add more than that another time, but for now, that's what I've got. So this is what you need to keep. So you need to keep every game week. You want to find out what their minutes were, expected goals, expected assists. This is all cumulative, but you can mess around with the data later. Total points, DefCons. I've got save bonus and BPS I've been saving, although I'm not actually using it, but I thought I might use it, so I've just been saving it just in case. Played, XGC, goalkeepers. This is XGC. I'm gonna have to do something there. That shouldn't be 0. I don't think. Goalkeepers. That's so position. Oh no, this is position 2. I'll have to talk about that in a minute, because for the sake of DefCons, you don't want to just know what position a player is. You need to know whether they're fullback, left back, right back, whatever, because they're a different I'll go on to the DefCons in a minute, but that's position 2. Team code, yep, fine. Versus code, who they were playing in that game week. This will be, yeah, just loads of details about that kind of stuff. I've also got worked out exactly the DCs they got in that game week and exactly the mins they got in that game week, because all of this is cumulative. Yeah, I feel like I should explain that more, but I don't want to get too lost in the weeds. Yeah, this is the code. That's a very complicated code. It looks very complicated. I think I'm just going to leave it there. If you want to figure it out, have a look at the code. Get yourself Claude. Just search that, copy and paste that code, give it to Claude, say what's going on here, and Claude will tell you. It's getting a bit like that. A bit cheaty nowadays with AI. AI tells you everything nowadays. So anyway, that's so all my data, I put it in a data bank form, and then I will copy each game week. My plan is to just copy it onto the bottom there, and it's just each game week I'll be copying it onto the bottom, and I'm going to have this big Databank, and when it gets too big, I'll start deleting stuff from the top. I'll probably save it in a file somewhere. So that's that. Let's go through the model though. Let's go through the model because then I can kind of talk about other things as we go. So here's the control panel. Control panel. I've got all these blue boxes are manual things that you can override. You can adjust, which I may have gone too much because in one sense you want to keep it simple. There's like loads to think about there, so I may actually delete some of these, link some of these. The whole model I might change as I go. Lots of changes. Anyway, you put the current season in that format, and the last game week at the pre-season is just 0. And then yeah, maths will come off of that. So the first point is 1 to 60 minutes. So let's get into the points. This is like the interesting part. This is the interesting part. And this is the way I wanted to work it out. Because before I was just giving every player 2 points. A blanket 2 points. But that's not quite right. And especially because it's even players like Madueke, Martinelli, even if you think they're going to play, their minutes per start rate was low enough that they might not. There is a chance they won't get that second point. So the minutes are kind of important, and plus I wanted to do it properly. So yeah, the first, how to work out a player's percentage chance of getting 1 appearance point. All you need to know, all they need to do is just get on the field. So they don't even have to start. They just have to appear, even as a sub, they can get this point. So most players' percentages will be pretty high. And the way I worked this out was to do unsubs per squads made. So to figure out a player's start rate, you got the playing time data. This is all from playing time data. I should probably get into the start of this in a minute, but this is playing time data, and you can get there each player's starts, subs, unsubs. So that's the number of times they've made a squad. So if you look at like somebody like Lewis Skelly, he's interesting. Squads made, he's made the squad 37 times. Almost every single game of the season he made the squad. But he only started 5 times. He came on as a sub 15 times and was an unused sub 17 times. So the amount of times he would have got at least 1 point is actually 20 divided by 37, I think. It's always, no, have I done that right? Unsubs per squads made. So it would be 17 divided by 37. See, this is where I'm going to have to remember all the math. There have been 2 weeks of like, it's quite difficult. Well, these kind of like little things, little bits of maths, like stretch your brain sometimes. Stuff that you probably did really simple in back at school. I always forget like about averages and how to divide by this or that, or whether it's 1 minus this, and but this is like, so I have done if and that is 0, just put not otherwise it's 1 minus that. So it's 1 minus 1 unsubs divided by squads made. And I've multiplied it by 99 because I figured there's no player is absolutely 100% guaranteed to start. There's always something that can happen. You can get injured in a warm-up. So unsubs divided by squads made. Yeah, it's not clicking in my head, but I'm too tired. But yeah, it's something like that. And this current season, so I've got last season's and this season's, and this current season there's no data, but on the control panel I've got it, so you can set it, either use last season or this season's data. That's gone now, I don't need that, I don't think. Last season or this season's data, and at the moment I'm just using last season's data. So when I said about all these pivot table stuff, all the stuff I'm keeping, XG, XA, XGC, that stuff I'm going to be able to roll across the season boundaries. So that's going to be long form, short form. But there's other stuff I didn't really need to do that. And so your unsubs, your start rate and stuff like that, I didn't feel like I needed to do that. It makes things more complicated as well. So I've just done previous season and this season. Same with yellow cards. It just feels like, the season break is actually quite definitive anyway, because like if a player has a certain start rate last season and then this season it's a new season I don't know. It feels like a more of a natural break anyway. So I'm just using previous season data, last season, and this season in a combination. So at the moment, it's just previous season's chance, and that's the point. So that's his chance of getting that 1 point. There it is. So Ray is like 99% chance. Skelly's 54% chance of getting that point. 17 divided by 37. Yeah, because it's like his 46% chance that he'll be an unused sub. That's why it's 1 minus that, right? And then there's one other thing to say, though, about this, which is that at the end of all of this, I actually want a couple of different, two different metrics. I want a metric that is going to measure if a player starts, and then another a metric that is going to measure like their true, what I really think they're going to get based on the minutes, probability of starting and stuff. And so this metric, if starting, because at the end of the day, I'm going to have this is my final sheet, and sometimes I just want to know what a player's predicted point score, if they're presumed to be starting, will be. Because the minutes, they're always sometimes hazy. So just give me the raw, if they're starting, what they're going to score, and I'll override the minutes. And in that scenario, on the if start score, it's just 1, because if they're starting, they get the point. So that, but if they're not, if I want to go by the true score, the true points, then I will use this. Anyway, let's not get hung up on the first point too much. 60 minutes. So this is the next point. What are the chances of a player getting to 60 minutes? This one I figured out before I learned about Poisson distributions, although I don't think it matches quite the same from what I double checked this. I don't think it matches quite the same. I've used this trend thing though. Another thing that AI helped me out on. I don't know if it's great. You can write like a list of like, this is minutes per start. If a player averages 90 minutes per start, you can manually change this. And I've just put it as like, they're probably very unlikely to get subbed off before 60 minutes. A player who averages 80 minutes per start, giving them a 5% chance they'll get subbed off before 60 minutes. Going down to 50, 60 minutes per start, I've given them a 50% chance. I don't know if that's perfectly accurate, but that's what I've done. These numbers were based on me just looking through a dozen, 2 dozen players, and just roughly thinking, oh, this is about the rate that they get subbed off at. So I'm doing more of my hazy, just figuring it out on the fly stuff. But it's the best I've got at the moment. So that's just a little, so you look at a player's minutes per start rate, and then this will be the chance that they get subbed off before 60 minutes. So players like Madueke is quite interesting because his minutes per start is quite low, 64 minutes per start. So he's quite close to that threshold. And so he comes out at 62% chance of, if he starts the game, what is that? 62% chance of getting that second point. Yeah, when I say if he starts, all of the rest of these are if start. So it's a weird one. So this first appearance point, the if start score is that 1. You just give him the 1, and that's the true one. But all of the rest of them are assuming a start, because at the very end, I'm going to then apply the minutes, the start rate to it, because that's how you do it. You got a if start percentage, if start score, and then, but if they're only 50-50 going to start, then the probability of them getting those points is 50% of it. I think that's the way I've done it. I'm fairly sure. So Madueke is there, 62% chance if he starts of getting beyond that 60-minute mark, which is fairly low. So he only gets 0.62 points for that second appearance points. Obviously, Ray is going to get it. I've given him 98% because I've just, rather than 99, I thought there's an extra chance of like well, this is presuming a start, but there's an extra chance of you getting injured or something in the game, not making it. So I've just capped it at 98%, arbitrary. It's just using previous season's data. So that's that, and that's those points, number 2. Number 3, save points. Saves per 90 divided by 3. So again, previous season's data, you find out how many saves they've got using the API. Some index, previous season's data. You just highlight the column you want, and then you match that code, which I should talk about now really, with the code in here. I've started using the code rather than the player name, because I've noticed that player names sometimes change from season to season, which is annoying, but the code doesn't. The team code does, but the player code never changes. I don't think so, from what I can tell. So that's nice. So I've been using the code instead. So you match in saves, you match that code with the code here, which is in the 4th row. And again, like when you use VLOOKUP, that's annoying because sometimes you want to go backwards, and VLOOKUP you can't go backwards, but index and match you can. So that's another advantage of index and match. So anyway, 60 saves per 90. I've got his minutes there. Same thing. So saves divided by minutes times by 90. That's his saves per 90. And then just divided by 3, because you get 1 point for every 3 saves. So Martinez is averaging 3.02 saves per 90. Divided by 3, he's probably going to get 1 point per game. Same with Bizot. But Reyes probably only got a 50-50 chance of hitting that threshold. That might not be perfectly accurate. Maybe it's a bit more of a curved line. Might not be quite as linear as that. But that's the way I've done it for now. It's easy enough. That's good enough for me. I'm not... Better models are probably going to go even deeper than this, but I'm trying to keep it relatively simple. That's the save points then. Yellow cards, I've just used again last season's yellow card rate, so same as saves. Yellow cards per 90. Raya hardly got any, some get a lot. Jesus got loads. He kept coming off as a sub. He kept coming on as a sub and getting a yellow card in like 5 minutes. He did that like 3 or 4 times in a row. So some of this might be skewed. I've actually turned the red cards off because of that, because it kind of skews things. I've just figured with red cards, I'm just going to treat it as an unlucky thing, like own goals or something, or penalty saves and things like this. I'm not going to measure for it. It's just an extra lucky or unlucky thing that happens. Technically, there probably are some players who are more likely to get a red card, so I'll have to just remember that and keep that in my judgment. But generally, I'm just going to ignore that, because there were some players who didn't play that many minutes and then got a red card, and now it takes too much, like Lewis Cook or something. It takes too much of their points off of them. I could do a minutes filter. The red card thing, you really need like 3 seasons worth of data. I feel like if there's a rate there, or you need a certain amount of data, and if a player doesn't have that much data, then I should just kind of have some kind of base average that I use, unless a player has more data than that, and then I can go above or below that base average. That's probably the way I should do it, but at the moment I've just turned it off. And yellow cards, I probably should... Let's see, I'm still tinkering with a lot of this, so I probably should have a minutes filter. Maybe I do. Previous season's yellow cards. Yellow cards per start. I don't have a minutes filter. So maybe I should, because like Jesus looks a bit skewed. But then I think I concluded that if that's his rate, it's still... I probably need a minutes filter. But at the same time, if he keeps coming off the bench and getting yellow cards, that's what he keeps doing. Like, maybe that's just his character. He comes off the bench, gets loads of yellow cards. So I don't know, maybe I don't need to adjust it too much. Yeah, I do need a minutes filter somewhere though. That's a problem I haven't solved yet, actually. I may have been something I should have done at the start of this model. And then also another thing I'll say is, like, a lot of the times with saves here, I've done saves per 90 because keepers play 90, but most of these metrics I've turned to per start metrics rather than per 90. And a per start metric is the per 90 metric multiplied by the minutes per start percentage. So if Madueke is playing 64 minutes per start is his average, he's only playing 71.11% of every game. And so his yellow cards per 90, well, he actually hasn't had any yellow cards apparently, but whatever it would be, he's not playing the full 90. So you have to multiply it by that percentage as well. The same with a lot of this stuff. XG, you've got a player's XG per 90, but if he's not playing the full 90, you've got to multiply it by the actual percentage portion of the game they're playing. So that's yellow card, red cards, and that's per start. So I'm using that. That is that. Bonus points then, yellow card, red cards, bonus points. What are we doing? Bonus points. Yeah, start. So I think basically I've done, again, it's last season's, previous seasons, and this season's. I'm not rolling through it at all. And I'm basically just using last season's, previous season's. That's how many bonus he's got. That's how many BPS he's got. This is, what is that? Is that some sort of filter I've applied? BPS times by that times by minutes per start. Oh, that's the BPS start. I can't actually fully remember what I've done with all this stuff. Basically, I was trying to figure out a way to convert BPS to a prediction of how many bonus they're gonna get, but I ended up concluding that it's not really very good. So at the moment, I've just set it to 100% bonus. It's not, the only time the BPS comes into it is if a player hasn't played a certain number of starts. I think I've added it at the end there, but there's a filter, and if a player hasn't played a certain number of starts, so for the bonus, basically it's bonus per start. So that's their bonus per 90. No, it's just their bonus per start. That's all I've done there. Why did I do that for? Because it's not really per minute. I think I concluded that it must be per start is a better way to do it. And that's why I've used the full word start rather than ST. ST is when you multiply it by the minutes per start. Sorry, it's getting probably a bit confusing. But that was the conclusion I came to, I think, that it's just better to do bonus per start because you're probably unlikely to get bonus if you don't start. Yeah, except some of this bonus, I don't know if that's right. But that's what I've done for now. I might have to double check a lot of this. And then any player that hasn't had more than 5 starts, I've used a metric that tries to calculate their BPS and convert it to a prediction of what they're going to get for bonus. The average BPS per start was that. The average bonus per start was that. And so the bonus to BPS per start factor ratio is 0.02. So whatever BPS somebody has, if you just multiply it by 0.02, you might get to an approximation of what kind of bonus they're going to get, is basically the thinking, if that makes sense. But basically the bonus thing is basically bonus per start projected forward. But I might need to revisit that. Anyway, it comes out about right. About right, I think. Gabriel averaging about 1 bonus per game. And then the assists are just, you just want to get, so this is where I've started using the long form and the short form. So I've switched, so I suppose I better talk about that. Long form assists and short form assists. So this is the long form assists here. And so I've got a different minutes metric on this one because it's not just last season's minutes, it's the long form minutes, because you want to find out how much XA they've got and then how many minutes they had, and then divide the XA by the minutes. So have a look at Saka or something, 7.16. So here's my data bank, and pivot tables, you get a new sheet, insert pivot table, use this data, all of this data. If you put everything in a table as well, last season my last model I wasn't using tables very much. I don't know why. I wasn't familiar with it, but I've started getting used to it, and it does seem to speed things up and make things easier. So you just take the whole databank table, put it in a pivot table, and then what have I done here? So this is just, you put the code on the left, that's the player code, will be along the left. I've also got a keep row, which I might talk about. There's an extra column here for keep, because in the previous seasons there's a bunch of players that just aren't here in this season. They've all gone, they're not in the game anymore. And so I've made a little keep column. So a bunch of those players you don't need, because otherwise, if you get 2 seasons worth of data, maybe it would go over 1,000 players. Because there's a bunch of players who have gone. It probably would get too much. So you just want the players from this season. They're in that row. Game weeks along the top. There's a certain code I'm using to search for. And then it's the sum of their minutes. And then down here I made another table underneath that just has the code, this game week code, and the minutes in this format. I don't know why I've literally done the same thing. Why have I actually done that? I don't know why I can't just search here. There is a reason for it, and I can't remember what it is. 21,111. Is it the same down here? 21.90. No, so maybe I'm converting it to, this is the per game week score. So that's what I've done. This is per game week. The top one's cumulative. This is per game week. And then in the model, to find that out, I use this code, which is a bit long. It's a bit long. You're indexing that bottom column, that bottom table I showed you underneath the pivot table, matching the code row, and then there's this kind of, so control minus that one. You're doing like that dot, so that's like a range. You're doing a range, and it's going from. So this is it again where I've probably had AI helping me here. E2, D56, C56. So E2, hopefully that it's still working. E2 is here. Column match 41. That must be. Oh man, so I can't remember all the stuff I've done. It seems to work. That's all I know. I've done some sort of maths there. Column match. Yeah, I can't remember what I'm doing here. I can't remember. You'd have to have a look at the sums again. But that you're doing some sort of maths there, and the minutes. So it's doing a range from one place in that table to the other, and it's just going to add. It's just going to sum all of that up and give you the range in between that. I'm gonna have to leave it there because it's too complicated to remember all the coding, exactly how it works. But it's something like that. So that's their minutes in that range, and then you do the same thing with an XA table here. Exactly the same thing. Find out how much XA they had in that range, and the 56 thing. So we're down here in the goals and assists section. So this is now I've got some long form, short form ranges. So I can change this to whatever I want. So the last 30 game weeks instead, you come to here. Now it's Raya only played 2,610 minutes in the last 30 game weeks. So you can kind of just adjust this however you want. I've added an offset, which is if you want to just go from last season, if you did want to offset it, so it's just like when we get to game week 3, if you want the long form to only be last season's data, you could put a 3 in there, and that will be, when we get to game week 3, that will be just last season's data. Or if you just wanted to go up to game week 36, this probably might cause an error actually. Yeah, it will, because I don't have more than 38. If that was like 35, if that was 35 game weeks of data offset by 3, then that will be Raya's data from game week 1 to game week 35 last season. So you can kind of control it. And if you wanted to kind of, as we go through the season, if you wanted to keep that one set to last season's data all the time, you can just put equals whatever this current data is there. Whatever that current, is a game week. So when it gets to 1, it's always going to offset to 1. When we get to game week 2, it will just go back 2 game weeks. So that will always stay on last season's data. Yeah, you can mess around with that. Anyway, XA per 90, so that's XA per 90 multiplied per start. I've also done a little extra start filter here as well, which you can also control. So that's their minutes per start rate last season and their minutes per start rate this season, because that might differ. And yeah, this might be where I've added too many controls, but I've added it for now. So you can kind of like choose how much of last season's minutes per start rate and how much of this season's minutes per start rate you factor into that sum. At the moment, it's just last season's. So that's that. Same with XG per start. Yeah, that was just, I won't talk about that. And that's the number of games they played. The number of games they played is not per player, it's per team. And that's important somewhere. I can't remember exactly where, or is it? Actually, it might be, if you have a look at the short form, it might be per player actually. What is it? I can't even remember. I think it's per team. So Melia was playing for Leeds. He's got a 7 there. They had a double game week in the last 6 game weeks of the season. And it probably would have been, I don't think Arsenal did get a double game week. So some 7s here. Gesand, Aston Villa, they must have had a double game week. These guys have got a 0, so they weren't even in the league, I don't think, maybe. I can't fully remember the maths of why I had that. But it is important, I think. Anyway, maybe it will come to me in a minute. So that's all the data. And so XA, XA per 90, XA per start. That's the percentage chance of getting an assist in any game. So last season, Saka 26%, Rice about 20%. And this is short form as well. So this isn't last season's. This isn't this season. This is short form. So this is the last 6 game weeks of last season. So Saka was actually 50-50 chance of getting an assist in the last 6 game weeks apparently. So if I want to use a bit of his short form, I could use that. And then it's just multiplied by 3. I think I'm just using 100% last. No, I've got 20% of that last short form, 8% long form. Anyway, same with goals. Exactly the same maths. Yep, let's crack on. Clean sheets. So this is going back to that Poisson distribution. So long form again. Long form XGC. So this one, XGC, clean sheets. No, so this is the XGC. I need to talk about the tables. So I've got, this is a whole other sheet that I've got. So you download your table from Understat. That's this season. That's last season. And you go to your table, and you've got a table, and this is this season's data. That's fine. That'll just be this season's data. And then I've got a long form and a short form. Long form XG. So I have got the team's long form XG. It's in the same column as the player's XG, the XG. So I can search it like that, like normal. But I have to search by their team code rather than the number code, because the team codes change every season, whereas the number codes don't. So you have to search by their name abbreviation. And then the XGC is separate because you do get a player. The API does offer XGC per player, but it changes depending on a player's minutes that they played and stuff. I want the team XGC. So this is a separate pivot table, again drawing from the Databank, and this is the team's XGC. I've all tried to line it up so you've got a big gap before you get to this form here. Yep, so it's the same kind of principle. I can keep it all the same. So that is a team's XGC per 90. Yes, I've done it in the table. So that's their XG. Again, that same kind of like sum maths that was a bit complicated, but that's looking in the XG, matching up that team's XG long form, XG short form, XGC long form, XGC short form. That's how many games they played in the long form. So this is why it kind of matters from a team perspective. And this is how many games they played in the short form. Why does that say? Oh, that says 38, but ignore that. These promoted teams, I just had to kind of override. So I've just put all of their data in just like the last game week of the season, just in one big, so it won't make any difference. It'll be the same short form and long form. But some of these teams like Crystal Palace, they must have had a double. Man City had a double. in the last 6 game weeks. Yeah, something like that. I don't know why Melia came up though as a double. Maybe he was playing for Palace or something. I don't know. So actually, I might have to double check that. Guess and it's 37 as well. 7. So anyway, that's that, and then you get the long form XG per 90. You can work out from that, and their long form XGC per 90. And then I've got a long form understat fix. I fixed it because now do I have this? I might have the data somewhere that I did. I do have it. Let me pause it. 1 second. I actually can't find it. I can't find it exactly what I was looking for, but basically you look at understats XG predicted, and again this was informed by AI, talking to AI, and they tend to overcook one end. So where am I going to here? Control C 101, 102, and B 10, 1002. So 100 down here. This is the understat correction. So I've got understat XG model overestimates poor teams' attacks and underestimates good teams' defense. To turn off, just set both to 100%. So there was a certain correction. Yeah, and the XG tends to, when you look at the total XG, I mean, you might be able to see it on here. If you look at the total XG to goals scored, it's quite close here, but I think they tend to overestimate here. So this Wolves, they predicted would score 38 goals, only scored 27, 43 to 42. That one's kind of close. Doesn't look that bad actually when I look at it there, but I'm sure I did a study of it. I looked back through 5 or 6 seasons. I must have the data somewhere. I'm sure I looked back for a few seasons and I saw that there was a pattern, a familiar pattern that happened. Yeah, I definitely look back through a lot of seasons, and I feel semi-confident in the correction, but you can turn it off. I might need to double check where I got that data from, but yeah, there's an overcorrection. So I've fixed it, and I've used something called forecast linear, which it again is AI informed. I don't really fully understand it. And I've created so there's the XG or the XGC. If it's 2XG or 2XGC, that seems to align. But if you got a team's got 0.9 XG or 0.9 XGC, you want to scale that back a bit, 90% of that or something. I don't know. It seems to work. It seems to work. I've got to double check all of this stuff, but it seems to work. I felt confident in it when I first did it. Yeah, God, this is the problem. There's a lot of stuff I did that I have to I've forgotten already. But I think it works. I feel all right with it. Then that's the average. The average, because yeah, this is another thing that was quite mind-blowing to me. That was a really obvious thing that I wasn't doing at all. But sometimes when you get a player's average score and you want to know how much to boost it or drop it by, I was doing this whole complicated maths of taking a team's XG and then actually, well, I think I was taking it from the average, how far it is from the average. I think I was doing that, but then I was doing other maths to it and like weighting it and trying to kind of do a rough thing. But really, like if a team is averaging 50% more goals than the average, then your defender, when you play that team, you can expect them to probably concede 50% more goals than the average, or whatever they're predicted by. I think it's as simple as that. I'm not explaining that very well, but I was overcomplicating it, and I think you just get the average and the difference from the average, and that is the how much you move those players' points by, boost or deficit. I'll hopefully talk about that a bit more, make it a bit clearer. But short form, XG, XGC, the understat, fix, the average. And then this is the combination of the two, which I've got a weighting of in various places. Like you can use last season's and this season's, or long form, short form. I can't remember. This is where I've made it too complicated. Yeah. See, I probably should have done this video like months in advance when I'm really on top of it, but I wanted to try and do it before the season just to get it out there. Anyway, that's the combination, long form and short form. So there's a weighting of it. So if you've got 100% or 80% long form, 20% short form, that will take the weighting of it, which I like. And with the understat correction, that means Arsenal's XGC in this model, what I'm using is 0.83. Long form, it was 0.78. In the last 6 game weeks, it was 1.08. I'm giving them a 0.83. Probably won't get corrected that much. No, they might do. The defense might get corrected a bit because they tend to underestimate good teams' defenses, I think. Overestimate bad teams' attacks. Something like that. So that's that, and that's the average. Okay. So, and then when we get back to XGC, so that's the XGC I'm using. Well, that's the long form XGC. What have I done here? That's long form XGC. And then that is the long form percent clean sheet per start. Oh man, my brain is shutting down. What have I done? XGC. That should just be the normal per start. Yeah, okay. So originally it was simple. Originally I just took that and I did the EXP brackets minus that, and I closed the brackets there. I've decided to add more things on now because this is me entering fiddling phase. I added the minutes per start because so somebody like Gabriel, he averages 90 minutes per start, but Saliba averages slightly less than that. It's not going to show up here, but a player who averages slightly less minutes per start is more likely to get the clean sheet than a player who averages more minutes per start. Because the earlier you get subbed off, the more you're going to get those clean sheets. Now, there's another process going on here, which is also you got to stay on the pitch for that 60-minute mark. So that's why I've also multiplied it by this number 2 here, which is their chance of actually getting to 60 minutes as well. So there's 2 things going on. Yeah, so if I had just done a team's XGC per 90, done the Poisson EXP thing, you get the clean sheet chance for that team. But if a player gets subbed off, there's 2 forces happening. If the earlier a player gets subbed off, the more likely he will be subbed off before his team concedes. So that metric's going up. But then a player also has a chance that the sooner he gets subbed off, the more chance he'll get subbed off before the 60-minute mark, and then he will lose his clean sheet. So that's why I multiplied it by this and this. Hopefully that makes sense, and hopefully that's right. I don't even know if it's right. I did double check most of this with AI, but could be wrong. So that's what I've done there, and then I've also got the chance of conceding 2 or more goals. So this is something I never added. Well, I think I added it into my model in the last season, but it was very rough. And this is another one where there's quite some simple maths to work this out. So the chance of conceding 2 or more goals means you're going to get a -1 point for that, for defenders and keepers. And the maths is you do 1 minus that, which we've already got that. So whatever their clean sheet chance is, 1 minus that. I presume it's the same and not the pre-fiddled number. That minus that multiplied by 1 plus that. Again, I don't fully understand the maths, but what you're trying to work out is, so what's the chances of a team scoring 2 or more goals? It's basically 1 minus the chance of scoring no goals or 1 goal. And you know the chance of scoring no goals because it's that's your chance of getting no goals. And so the chance of scoring 1 goal is something close to that. It's not quite that, and I think with AI help they've rejigged the formula, but it's something like that. So you've got the chance of scoring no goals, the chance of scoring 1 goal, and then you just do 1 minus that, and that's the chance of getting 2 or more goals. Technically, a team could score 4 or more goals, and you get another -1, but I've just ignored that. That's in my category of like all the peripheral points that I'm not going to look into because it's going to make it too complicated. So that's that. I really hope this is still recording, because if it isn't, I'm probably not going to bother doing this again. Let's keep going. Come on, nearly there. Where are we? So that's the clean sheet chance, and that's the +2 goals as well. So that's kind of nice to have that, because that's an important point. I mean, some of these players are losing quite a lot here. Emilio Martinez. Some of these teams have got quite a high chance of conceding 2 or more goals. So that's important. And then DefCons is going to be interesting. So no points for DefCons for keepers. Everyone else gets 2. Long form, and I've used long form and short form rather than last season, this season. So, you know, players like James Hill, you might be able to have a look at his short form a bit more. And so that's the long form DC. Let's see what I did here. Long form DC. So again, using this sum calculation in the pivot tables over here from the Databank, the range of long form, that's how many DCs they got in that range. That's how many minutes they had in that range. It might be using a different range. You got 83 here, 83. You got DefCon long form, short form. That's that range. That's 83. So it looks like I've set it so you can actually set it to a different range to the goals and assists. Which again, maybe I might actually end up making these all the same, so it's just simpler. But I think you can actually set it to a different range to the XGC, to the XG data. But anyway, at the moment it's set to the same. DCs, long form DC mins, long form DCs per start. So it's your DefCons divided by your minutes times by 90 times by your minute per start rate. And that's weighted with previous seasons, this season's again. Yeah, see, it does get complicated. I'm just about on top of it. And then the chance of getting DefCons, I think I talked about this, didn't I? It's again Poisson distribution. I spoke about that earlier, so it's the same thing. You go from that. Same with the short form, and then over here I take a weighting of the long form and the short form to get the final score. So Gabriel, last season he was hitting the DefCon threshold, predicted to hit it 42% time. That's not actually how much he actually hit it. I'm always going from the underlying data and predicting what could happen rather than going from what actually did happen. So 42% last long form, last 6 game weeks he was hitting it 46% of the time. 80% weighting on that, 20% on that, 0.84. There's his total points. Pretty good. So that's it. That's the model. This little bit here at the back end, I've got a bunch of things here because when you search, again, there might be better ways to do this. And in fact, now that I've got Excel 2024, I probably, there's a way that you can search called, I think it's called like fuzzy approximation or something like that, fuzzy name. So I might actually be able to override this, but because I did it in 2019, maybe I'll leave it. But when you're searching through FPL, some of these FBref forms, they have different names. So at the start of the thing of my spreadsheet, I've got the FPL name, FPL web name, that's coming from the API. Then I've got 2 more spots for extra names. And this one is usually the FBref name. And so wherever the FBref name is different to the FPL name, I'm going to put it in there. So David Raya isn't David Raya Martin, he's David Raya on FBref. And then at the back end here, I do this search thing where I search for that name, the first name, the second name, the third name, the fourth name. And then I've done this little kind of maths where it just makes sure that it only adds up one. Only as long as all those names are different, it should only pick up 1. And if it picks up 2, this maths will pick that up. It's kind of if the name, if it picks it up twice, it will divide it by 2. If there's ever 3 names repeated 3 times and it's the same, then the model will break. It just won't have it. So I haven't adjusted for that. But as long as there's no more than 2 duplicate names in these 4 first columns, then it will find it. And so that's previous season starts. This is all the FB ref data, basically. I just had to use that to search it. Yep, that's what I've done. Then I did the predicted points. So I'm going to keep going. It's going to be a long video. This is where I got a bit worried that the model might get slow, and it did get slow. When I was adding columns, the whole thing would take like a minute to add a column. This is, hopefully the monitor won't break. This is 76,000 columns, 1,000 rows long. So in my last model, basically you got your predicted points now of the players, but now you need to run it through the fixtures. And in my last model, I went widthways instead of lengthways. And so I had all the game weeks, because I just did it the way my brain naturally thought about it. So I had all the players down the left, and then I was like, right, game week 1, game week 2, game week 3, like time-wise in my brain. But of course, all the formulas, I had to just copy and paste the formulas, not just 38 times, but 76 times. And the reason why it's 76,000 rows is because I want to accommodate for double game weeks. And so I've split every game week into 2. And the second half of every game week is usually, at the moment, is just nothing. Everyone gets zeros. There's no fixtures, so it's just zeros. But if there ever is a second game week fixture, then the model will pick it up. So I've used that. If there's ever a triple game week, the model won't pick it up. In fact, it might break as well. I don't know. So as long as there's no triple game weeks, I should be safe. Shouldn't be. Was once. So we're going downwards. I was thinking of doing a pivot table for this, a power query, because it's very big, but I decided to just wing it, and at the moment it seems to be working all right. So yep, so I've got some codes here. That's just 1 to 76,000. There's the game week. Game week 2 is just doing some maths to show whether it's the first half or the second half, and then I've got a little code, so it's 1-1 or 1-2. So I know all the way down. Game week 38 1, game week 38-2. There's the player code. 1,000 times. That gets repeated every 1,000 times. The player codes from here, because you've got like 1,000 players in this model. 1,000 spaces. Team position. The second position. At the moment, I've just hard coded that in the model. So Timber's a right back. Skelly's in as a left back, but I don't know whether he still is. Calafiori. This is coming from Transfer Market, and I've got a whole other spreadsheet called Squads, which I might upload or talk about another time. I've got the squads. I just copy and paste the Transfer Market squads per position. Maybe I'll talk about that another time. You go to Transfer Market, squads by position, copy and paste that table into my spreadsheet, and it will convert automatically and just tell you all the players' positions, and I can just very quickly look all these up and get their actual positions. And then at the moment I've just copied and pasted that as values, hard values, so because I wanted to keep all this in one spreadsheet. I didn't want to have to kind of link up to other spreadsheets, and squads is a very big spreadsheet, so I've just hard coded that. That's all I need. So that's that. And that's basically going to come. We need to start thinking about, well, in the tables, here's the DefCon tables, and you've got like all the teams, and then per position how many DefCons they opposing positions accrue against that team. So that's why you need the specific, because then you know what to multiply by. We'll come on to that again in a minute. So here's the points. This is predicted points then. So we want to, at first we're building a if start total, and then we're going to build a true total. So you need the if not start total, and then you kind of make a combination. So we're starting with the if start total. So if they're starting, this is why it's just 1 point. If they're starting, they're going to get that first appearance point. That's just done. Their chance of getting a second appearance point, I've spoken about that already. We'll just use that. Number 2 is literally just, I'm just copying these from the model. That's the second one. These first 5, originally I was thinking these were just going to be static, because this is another thing. My last model, I worked out a player's predicted score, and then I just multiplied the entire predicted score by like 30% or 130% or 70%, give it a boost or a decrease. But that's not technically right. Like, a player's chance of getting 90 minutes or 60 minutes or whatever doesn't really change depending on the opponent. Maybe it does, but like not really, not much. A player's yellow card and red card chance doesn't really change depending on the opponent. Again, if you want to be really fine-tuned about it, maybe it does, but I'm trying to just keep this simple. The save chances, I decided I would adjust it. So that divided by that. That's the multiplier. Versus XG divided by the LA, the league average. So Arsenal playing Coventry game week 1. Coventry's XG per 90 is 1.26. I've got to talk about that in a minute. 1.26. That's my estimation of it. So below the average is, and the average is 1.53. So 1.26 divided by 1.53 is 0.82. So that's 82% ish. So, well, it's 83 it says here. And so Raya was getting about a 54% chance of getting a save point in any game, but you've got to multiply it by 83% when he plays Coventry, because their XG is 83% lower than the average. So he's probably going to get less save opportunities. And so he's actually probably only got a 45% chance in that game. Make sense? So that's that. So I have adjusted the save points to the fixtures. Yellow cards are kept the same. Red cards have kept the same. It's just 0 at the moment. And then all the rest of these points are going to be adjusted by depending on the fixture. So this is the fixture. This is the fixture, and this is where you need the fixture list from where I showed earlier, all these API stuff, these spreadsheets. So you go back to kind of like A1 and type in right fixtures. I've just written the wrong name in. Oh, that's not how you spell fixtures. Fixtures. Get the fixtures like that. Copy and paste it into here. By the way, I haven't actually tested this for game week 1, but I think I'm going to have to copy and paste the cells as values from 2 downwards and not over the headers. I'm still learning how to use tables more because I never used to. So I think you have to go from 2 to the bottom and copy and paste, overwrite the values. Otherwise, these lose all their references. I've got this fix helper doing some maths to help convert that. So that is looking at the fix helper, and it's lower casing the away fixture. So it's going to this fixture helper here. Here's the game week. You've got a code, so that's going to be the game week and the team code. Away team. That's the away code, game week and the away code. Home, away. So that's the team. You have to kind of like link it up with this teams to find out the name, because the code to the team. Got a code there. Arsenal game week 1, Coventry game week 1. It's just started to use codes, and then you can kind of look for codes here. So it's match team and plus game week 3. So I'm matching this team and let's say game week 3 plus game week 3. What's game week 3? Oh, that one. Sorry, that code, yeah. So it's matching that team with that code. So in fixtures, it's matching this column here. And then if it makes a match, it will tell you who they're playing. And you draw that column back. Something like that. I don't want to go into too detail, but that's how you figure out who they're playing all the way down. Versus XG, and now you can just VLOOKUP or index that table. I don't know why that table's so big. Not sure it needs to be that big, but you just go into this table. I don't think it needs to be that big because I think I've already done the maths on it, but you should just be drawing from something over here. I might have a look at that again in a minute. But anyway, you get the Coventry's XG and their XGC. You look at the league average XG, league average XGC, and then you're going to get what's that, versus XG per 90 divided by the average. So this is the factor. This is the multiplying factor. So why does it say 1.17? It says 0.83. Yeah, so sometimes you've got to know whether to go up or down with some of this stuff. XG, yeah, that's like yeah. So I've had to go up with that one, because if they've got, yeah, I'll come on into it in a minute. It depends on whether you're boosting your defenders or forwards and all this kind of business. But that's the multiplying factor, 17%, 4%. I think Hull somewhere. Who's playing Hull? Liverpool or something like that. Hull. Oh, this is Hull away. They got like really big numbers. There's a 67% there and a 43%. Huge numbers are getting multiplied by, because they seem to be particularly bad. Bonus per start. That's the expected bonus per start multiplied by the multiplier, which is the bonus. I was just piggybacking onto the XG multiplier, because I'll tell you what I've done with the bonus. If it's a defender, I've piggybacked on the XGC booster multiplier, and if it's or a keeper, and if it's a forward or a midfielder, I've piggybacked on the XG one. So Raya is a keeper, so he will be getting the XGC, so he's getting like a 4% boost, because he's playing Coventry, and Coventry are a little worse, like 4% worse than the average. But an attacker like a Saka is there. He's getting a little boost. That doesn't seem enough, actually. That doesn't seem enough. But is that actually Saka? Or have I got the wrong guy? Yeah, that is Saka. I feel like that should be boosted more, but that's supposedly like 17%, unless I've got some other things going on there. 0.72 times by 1.17 should be 0.84. What have I done? What have I done there? I'm gonna have to double check that, but supposedly I think that's. I mean, it looks like he's probably only getting a 4% boost there. Is that what's happening? 0.72 times by 1.04, 0.7475 ish. Yeah, 75. So he should be getting a different boost. So I might have to just double check that. And bonus per start. If it's a keeper or defender, I've done it the wrong way round, haven't I? XG per. Okay, I'm gonna double check that. I might have spotted an error there. I'll put a pin in that. Anyway, let's carry on. And that's the points. XA per start. It might be right. Half the time when I think I've found an error, it's actually not. It's just me thinking it is. But I'll double check it. XA per start. Yep. So that's drawing table column 7, the finished guess. That's the multiplier. So it's multiplying by the multiplier. Multiplying by that. That's multiplying by that. So this is his chance of getting an assist in that game. Yeah, so Saka's assist chance should be going up a lot more than that. Should it? I'm gonna have to. I don't have too much dead air in this video. I might have to double check all this stuff. And then there's also a FA boost. So this FA boost is fantasy assist boost. This is something else I looked at, where if you go back through last season, I actually went back through several seasons, so I double checked this, and it seems to be a real. I'm quite confident in the number. And if you go back and look through if you look at the FPL predicted XG, 494. At this point when I did this study, 494 goals predicted, and the actual amount of goals was 496. So their XG to actual goals is very close. But their XA that they predict was 318 assists, but there was actually 444 assists, which is like a 40% more assists than actual assists. And I went back through the last 4 seasons, I think it was. The first season, it was like 200% off or something. It was crazy off. And AI said that quite often happens when you got a new model. So they were just bringing in XA, probably XG and XA into their model. So maybe it was just very out of sync. But then the next 3 seasons, it's averaged about 40%. There are 40% more assists than expected assists in their model. And so they're probably using XA as a kind of actual Opta assists and not including fantasy assists. So I just multiply. At the moment, I'm multiplying everybody by an extra 40%. Everybody's assists by 40%, which might seem like a lot. But I can't see what I've done wrong there. I've done it the same blanket 40% for every player, because fantasy assists are a bit random sometimes. But that's what I've done. I might tinker with that or change it if I figure it's wrong. But at the moment, that's what I've done. So that's that, and then XG multiplied by the multiplier. Again, I'm multiplying it by the XGC. Let me just double check this, man. XG times by the XGC multiplier. No, that's right, isn't it? So that's right, because their defense is actually not that much worse than the average. It's only 4% worse than the average. So he's only getting a 4% boost. That is right. I'm overthinking it, aren't I? The bonus, XA, XG, Coventry's defense, I mean, whether you think that's right or not, this is just the numbers I've ended up with. They've ended up with about 4% above average. And that's why he's only getting a 4% boost. It's the defenders. Their attack is 17% worse than the average. So defenders and keepers are getting a 17% boost. Yeah, it's right. Panic over. So that's fine. Then the clean sheet chance. So again, this is kind of interesting. You work the clean sheets out game by game, the XG chance. So that's the final XG. So as I said, like Arsenal's 0.83, long form and short form weighted. Then you work out the clean sheet multiplier. The clean sheet multiplier is so it's just again, so Coventry are like 17% worse than the average. And so I'm multiplying that by, see, it wants to go down, doesn't it? That times by, yeah, what have I done here? Yeah, no. So this is why I've done kind of 1 plus 1 minus that, because you want to have it a positive. You want it to be positive for defenders and keepers. But when it comes to clean sheets, this rate here, it's just going, it's multiplying by 83%. Because you want that number's going to go down for that one. So it's 0.83 times by 83%. So their XGC predicted for that game is like 0.69. Arsenal's against Coventry. And then you do the same little simple maths of like Euler's number, whatever it is, Poisson distribution. And so they've got a 50% chance of clean sheet in that game. And I love that, because I see on Twitter people kind of giving clean sheet probabilities, and it's good to get that. Now I know how to get it. So I've always kind of like wondered how they work it out. Although other people do it from the bookies odds. I don't know how to do that yet. That's something else I'd like to look into maybe one day. But let's keep it simple. So that's the clean sheet odds. That's how many points you get for clean sheets depending on your position. So that's the predicted points. Same thing, same maths I spoke about earlier. 2 plus goals. That's their probability of conceding 2 or more goals against Coventry's 15%. You get -1 for that if you're a keeper or a defender. Minus 15, 0.15. DefCons versus DefCon per position. So this is where versus DefCon per 90, depending on the position. Then you've got the league average and then the multiplier. So what is this then? So this is going to be index. Let's have a look. Gabriel is a centre back. He's playing Coventry, so it's going to match that with this table here. He's playing Coventry. He's a centre back, so you're going to get an 8.04, which is, again, I've fiddled the numbers with the promoted teams, but the rest should be right. The rest is a combination of long form and short form weighted. and you've got 8.04, it should say there. So that's what it says, and then that's the average for centre backs. The average is 8.76. That's the 25-26 average I've put there. Yeah, so the average is I can't. Well, what have I done there? I probably could get the long form and the short form average, but I don't know whether that's what I've done with. I've done 25-26 average, and then that's the current average. I must have thought something at some point there, but anyway, I've used that 25-26 average for now. And so the multiplying factor is that Coventry give up less DefCons to opposing centre-backs than the average. And so I've got to multiply Gabriel's chance of getting DefCons by 92%, giving him a drop-off. See, once it all works, it makes sense, I think. So that's good. So he normally gets a higher DefCon chance than that, but he's going to get dropped down to about 42% this time for this game. You get 2 points for a DefCon, so he gets 0.84 points added to his points. There you go. I think in the last section I showed he was about 6 points, his average points. He's getting boosted to about 6.64. Then you get the home and away advantage. This I have applied after all of this stuff. This is just going to be a blanket application. I've looked back through previous seasons' data. The 5% boost or deficit seems to be quite reliable. Again, obviously not all the points. Appearance points don't get boosted by home or away particularly, but other points do get boosted more. You can have a lot more goals. The goals and assists go up at home and go down at away. Defensive saves and DefCons go up when you go away than when you play at home generally. But because it all ends up equating to about 5% for the whole thing, I don't really need to go through each individual score to do up and down, because if the blanket is 5%, if I go through all the individuals, it's just going to end up at 5% anyway. So I'm just saving myself some maths, really. So I'm just doing a blanket 5%. Seems to work. I'm happy enough with it for now. Big blanket 5% up or down, home or away, and that is the score that they end up with. If they're going to start, if each one of these players starts, this is the predicted score they'll get. So they'll all be fairly high. Apart from the promoted teams, I've got to figure out, and I haven't added a minutes filter to catch weirdos like this player. But that's that. Nearly there. Starts per squad's made. So then you have to, then I had to work out an if not start total. Because in order to get the true total, the true total is how many points do I really think this player is going to get? Not if they're going to start or if they're not going to start. What do I actually think is going to happen? And the true total is going to be their probability of starting. But then if they don't start, they may still come off the bench. They've got a certain probability that they'll come off the bench, and they could still get a certain amount of points off the bench. So you've got this is their probability I have of them starting at the moment. This is the probability they have of starting. So like Ray is 100%. His starts per squad's made. Every time he was in the squad, he started. Some of them, Gabriel was a bit lower. Saka's like 78, was that? 94, don't know which players these are. But some of them are a bit lower. I can manually override this as well, but most of the manual override I'll do on this page. Model 1, what we've done there. So this is where instead of that first appearance point, if they start, I just gave everybody a 1. But if I'm trying to figure out the true total, I want the actual one that I came up with. So that's the actual one. T1 is if minutes per start equals 0, then do model 1. If it's not 0, right, so I have to adjust that, because if I adjust this manual start, then this first appearance point, like if that's a 0, sometimes you get a flag and they've got 0% chance of starting. Well, then they've got 0% chance of getting that one appearance point. So that needs to be adjusted. It doesn't look like I've actually adjusted it though. This might be not adjusted though, because players like Saka, even if they don't start, there's very likely to come off the bench and play. It might be something like that, some sort of maths I've done there. I can't remember. I have to have a look at the code. Minutes per sub divided by minutes per start. Oh, what have I done? 0.2. The model. What is all that code? This is minutes per sub. Because the minutes per sub divided by the minutes per start. I can't actually remember. This was quite complicated maths. It was stretching my brain at trying to finish the model. Because you've got players coming on. If they don't start, they can still come off the bench. But then you still need to multiply that by the minutes per start rate, I think. I don't know. Or is that just the rate? I can't remember. You're going to have to kind of figure it out. I can't remember what I've done there. And then if they're not starting, I've got added only so many of these points. So 1, 2, and 3. If a goalkeeper's not starting, he's probably not going to get the save points because he probably won't play at all. If they're not starting, I'm not using that number 1 or number 2 there. Yeah, because these are... I don't know whether I should use 1 or not. I don't know. Times by this thing. I can't remember what I've done. I remember feeling good about it, but I don't remember what I've done. I'd have to double check the maths. That was a lot of maths. You end up with a true total. Yeah, it's something to do with if a player starts, if they're not starting, they might still come off the bench, and you've got to kind of work out the weightings of that. Yeah, I think it's right. Although he's got a minus 0.2 there. I might double check all this one day. Anyway, that's the true total. That's that. So that's all the things. That's all the. That's everybody's predicted point score right away through the whole season. And then predict. This is going to be the page that I end up sitting on the most with all just my data, all the stuff that I want. And these are kind of the game weeks. So if I want to look at like game weeks 1 to 10, type in 1 to 10, and these update. And these are like sum ifs. So again, my last model, I had just these massive tables where I was adding up all of the cumulative numbers, separating them into per game weeks, then doing these massive sums. And you can just use sum ifs apparently. This is like code that I didn't really know you could do. So you do a range or something like sum if, then from that game week to that game week. Seems to work. I don't know. Sum ifs, so you've got the if start and the true start, true points. That's the start rate, so that's like starts per squads made. If they got a flag, this is my manual override of their chance of starting. Sometimes I'll just use this to just, if I'm just not very hot on a player, I'll just knock them down a few pegs. Minutes per start rate, yeah, all my data that I want. I need to start playing around with this page, make it a bit nicer and stuff, get everything I want. And that is the model. So that is it. Yeah, I think that's a lot of talking. So I think I'll stop there. I did run it through the solver as well. I've been getting into this again. Before I wasn't really very confident in it, but I'm starting to get a bit more confident in it. Oh, there's another video I need to share, which is that Sertalp does a video, the FPL Optimized guy, and he does videos explaining this. So I've pretty much just copied him with how to do this. This is exactly the way he does it on the video, pretty much. And yeah, I've done solvers. One thing interesting about the solvers at the end of all of this is that it's not picking Haaland. That's quite interesting. It's not picking Haaland at all. I did one where I solved it with, instead of doing integers, I did allowed for fractions. So you can have a fraction of a player just to kind of get a sense. And it picked 0.2 of Haaland and 0.8 of Igor Thiago. That was the best. That was the most amount of Haaland it would pick. And I've also started getting into this, which is a sensitivity analysis of the solver. Because one of the problems with solvers is it just says, it's kind of like, trust me, bro. It just says, right, just pick these players. And I'm like, well, how much is this player definitely a pick and how much is another player? Like, are these other players missing out by just a little bit? And again, if you do the fractions like that, Haaland was 0.2, you can get a sense of how close these other picks are. Now, I suppose Haaland, if he's 0.2, that probably means he's really close to being a pick. So maybe he is close. But the rest, if you look at the lineup, so Neco Williams was only 0.2 points away from being in the lineup, being picked. Neco Williams, apparently. So that's, I've seen some people go for him. I wasn't really paying attention to him that much, but there you go. This model doesn't factor anything into about like where I think the teams are going to go with their new managers and stuff like this. This is purely based on last season. But you got like Szoboszlai 0.6 behind nearly anything. This is 5 game weeks as well, so any player within about 2.5 points is only half a point per game week away from being in the lineup. So they're all quite close, which just makes me think. I mean, Mateta's a weird one for being up there. Van Dijk, it just makes me think. Just use your hunch. Just use your hunch. Anyway, so that's the sense. Tav was in fact, is Tav in the team? No, Tavernier is 0 points, 0 reduced costs. So that means he's like neck and neck. So you could just put him instead of Gibbs White or something. Like he's really close to being in the team. That's what it said. It originally had other players. The model was picking other players like Watkins, but I just pushed him down. Anderson, Bruno Guimaraes, Saka. I kind of felt like a Thiago, Declan Rice. These are all players that the model was picking. Sarr, Watkins, and I was kind of thinking, I don't know whether I fancy that. But these were players that the model was picking based on last season. And another interesting thing about the solver is that it's going quite big at the back. I forced it to play this formation: 3 defence, 4 midfield, 3 forwards at the moment, because this is the first 5 game weeks, and I've decided that's the formation I'm going to do. And later on in the season, it's going to be 3-5-2. So I can force that formation. And for the first 5 game weeks, there's still a question, though, even though I'm going 3 in defence, there's a question of like, well, how much money do I put in defence? And it keeps putting a lot of money in defence. It's got Van Heck there, although I think before it had Van Dijk in one of my solves. Gabriel, Mark Gay, and then Van Dijk or maybe Van Heck. I don't know about Van Heck. That's Brighton numbers. But it is going quite big at the back, like in terms of price-wise. And Bruno Cap, it likes, and it's not seeming to like Haaland. So that's interesting. It likes quite a solid midfield, like Mbomo, Gibbs White, Enzo, or Tav. These kind of midfielders feels quite solid. Calvert-Lewin, João Pedro, it likes. And then it did like Thiago, but I bumped him down, so it put Mateta in there. But that kind of thing. So that's what's happening. Sheesh kebabs. I'm going to stop talking. That's too much talking. Any questions, feel free to ask. I'm going to try and upload this spreadsheet now. As I say, this should be contained in one spreadsheet. So you should be able to just download this spreadsheet. If you've got a decent Excel, even 2019, an old Excel, this should work. It should work from scratch. Loads of ways to control it. I'm probably going to be tinkering with this, though, a lot. This I haven't adjusted. This was like DC rates. I'm going to stop talking. Oh, well, I should show you this as well. This was the promoted teams. If you promoted teams here, if you put their XG from their championship per 90 and their XGC, this website here figured out a multiplier. So you can figure out what their XG is likely to be in the Premier League and what their XGC is likely to be. So that's what I've used there. Data Between the Lines, Substack. I'll leave the link for that as well. Okay, I'll leave it there. Hopefully that was useful to some, and I'm going to have to actually think about my actual FPL team now for the next week. Okay, thanks for listening. See you later. Bye-bye.